All right, guys, Mr. King here. Today we're going to continue the converting using dimensional analysis, doing a few more problems. You will have a few problems to do on your own. I debated how to do this. I was pretty tempted to have you like work out problems on paper and maybe take a picture and send it in, but I'm not sure that everybody has access. I know you've got a Chromebook, which you probably can take pictures with. It's a little complicated though, so I am just making it a Schoology assignment, and I'm aware that you could easily just again look these up online. I know that's a possibility. It's very easy to do. I'm once again asking that you don't. So please don't just type these in online, find the answer, and click it and be done. I want you to actually take the steps that I'm showing you because it's a skill that's going to be important for you. All right, so first let me pull up the questions. All right, so this here is the PowerPoint that we were looking at. You'll notice this is after Thursday stops here. I'm just gonna do 3 example problems right now. And here's what I would suggest. Excuse me. While I'm working on these problems, maybe not for the first one, maybe the first one you just kind of follow along, but after that first problem, try to see if you can do these or start to do them on your own, okay? Because that's gonna be helpful in your practice. Because as you're practicing doing these problems, you're gonna be able to just check yourself and make sure that it's working correctly. Okay. Sorry guys, let me see, I'm gonna pause this real quick so I can try and fix this. Okay, I'm not sure what you saw or didn't see. I should be getting 2 monitors soon, which will help me a lot with this recording stuff, but I think I'm rolling now. Sorry about technical difficulties. So I'm just going to do this problem, go through the steps. Again, this time I would probably recommend watching. I'm just going to talk out loud. So first thing I got to do is I got to put this in scientific notation. So just starting here, I'm going to move it 1, 2, 3, 4 times to get a number between 1 and 10. So it's 4 times 10 to the negative 4th. It's negative because it's a little number. Don't forget to do that. I'm going to put that over 1. So now I'm going to multiply by some conversion factor. Okay. Now here's where you got to use those notes that you had, right? So the ones where I told you may need to write down or screenshot or whatever. I know that I would like to get to nanometers. So I know it in my head, but I'm assuming you don't. So let's look for nano. And I see here it says there are 10 to the 9th nano blank in equals 1 blank. And again, that blank is the base unit. In this case, the base unit is meters. So 10 to the 9th nanometers equals 1 meter. I'm going to remember that, and I'm going to write that right on my document here. So it said off to the side 10 to the 9th nanometers, I'm using the abbreviation, equals 1 meter. So when I look at this, I do not want meter. Right, I want nanometer, so I would like to cancel meter. So again, think about multiplying fractions. Where would meter have to go over here to cancel? Well, of course, if I put it in the top, it's not going to cancel. It would actually combine to make meter squared. I got to put it down here. So I'm going from meters to, and now I'm going to put the other thing I want on the other side. So I would like nanometers. And I'm really just recreating this right here, right? So the number 1 goes with meter, and 10 to the 9th goes with nanometer. Now, if I was to do the math here, notice what cancels. Meters cancel. That's it. Nothing else. But that's fine. The meters are gone, so now I'm just going to multiply across the top. And this is the dimensional analysis part. I'm treating these units like numbers. So multiply across the top, and that's 4 times 10 to the negative 4th times 10 to the 9th nanometers. And on the bottom is just 1 times 1 is just 1. So really the bottom's not going to matter. So when I multiply powers of the same base, I just simply add the exponents together. So my final answer is going to be 4 times 10 to the negative 4 plus 9 is positive 5. And that's my answer. 4 times 10 to the 5th nanometers. Okay. I'm going to go to the next problem. It should be on the next slide, but I've just got a copy of it here so I can write on it. So once again, I would encourage you to maybe just try to start, at least do the first step. See if you can set this up, right? So try to set this up, put in scientific notation, and put the unit beside it. We always have to write the units, and then put 1 on the bottom. Good. So you should pause this. Go ahead and try to do that. See if you can do it. Okay, hopefully give that a try. Now I'm going to show you. So once again, I got to move the decimal place to get between 1 and 10. Oops, I'm not on the right function. Okay, there we go. So now it's moving the decimal place 1, 2, 3 times, get 5.5. So it's going to be 5.5 times 10 to the 3rd. I'm going to use V for volts. And simply put that over 1. Time sign, division sign. Now I'm going to look up, right? So I want to go from volts to megavolts. Great. So I need to look up and see how many volts are in a megavolt, or how many megavolts are in a volt. And so once again, I'm going to go back to that page that you hopefully already have. And I see here, it says 10 to the 6th blank equals 1 mega blank. Once again, the base unit is that thing without a prefix. So in this case, our base unit would be the word volt. So every one of these blanks is really the word volt right now. So it says there's 10 to the 6th volts equals 1 megavolt. Okay, so I'm just going to write that down exactly like I see it. So I'll write that up here in maybe red. So I saw 10 to the 6th volts equals 1 megavolt. Now, be careful here, because experience has taught me that a lot of students struggle at this step right here because they end up flipping this, right? They end up flipping the conversion factor. So let's look here, right? We have up in the top, we have a volt, which I want to get rid of. So before I even think about what goes on top, what goes on bottom, I'm thinking about units. What unit do I put here so it goes away? Well, I have to put volts in the bottom to cancel. And of course, I would like to go to megavolts, and I know how to go from volts to megavolts. I have that conversion factor, so I'm going to put it on top. Now be careful. Here's megavolt. You're going to think maybe 10 to the 6. Maybe you know, oh, mega is a million, 10 to the 6 is a million, and that's great. But the number beside mega is 1. So I'm going to put 1 megavolt there, and this other thing, 10 to the 6 volts, goes on the bottom. So now when I cancel, volts cancel, and the 1s cancel. So now I'm done. I have megavolts. I have the unit I want. So I'm going to do the math. I'm going to multiply across the top. I have 5.5 times 10 to the 3rd megavolts. On the bottom, just 10 to the 6th. So I'm dividing powers of 10. I subtract the exponents. My final answer is 5.5 times 10 to the 3 minus 6 is negative 3 megavolts. And that's my answer. I want to point out something real fast here. Let me do this in maybe a different color. So right here, this thing in the box, ignore everything I've canceled out. 1 megavolt divided by 10 to the 6 volts, right? Remember this conversion factor, we said those two things are equal, right? So 1 megavolt is equal to 10 to the 6 volts. So I could replace, instead of 1 megavolt here, I could write that as 10 to the 6 volts. And look what it is. It's the same thing on top and bottom. Of course, we know if we have something that's the same on top and bottom, that's just the number 1. This whole thing, and that's what I'm trying to show you, this whole thing in the green square is really sort of a complex or fancy way to write the number 1. And that's how it has to be, because what happens when you multiply something by the number 1? Well, that's called the identity property of multiplication. The number doesn't change. If I take 5.5 times 10 to the third volts and I multiply by the number 1, I still have 5.5 times 10 to the third volts. And that's why this is called converting, because even though this looks different, it's the same. At the end of this, we're saying 5.5 times 10 to the negative 3 megavolts is exactly equal to 5.5 times 10 to the 3 volts. Those are the exact same number, just written in different units in different ways. Okay, I'm going to move on to the last problem here, next problem. So one more time, I'm going to encourage you to stop the video here and try it on your own. See if you can get this see if you can get this on your own, because that's going to be important for practice. And again, I know it's a little different because you could just keep watching the video. I know you don't have to stop, but I'm asking you to please stop, and it'll help you, right? It's a good practice. Okay. So, and I would, hopefully you tried that whole problem. If you didn't, keep trying, go to the very end of the problem. See what answer you get before you see what I'm about to do. All right, so now, hopefully you did that. I'm going to show you the solution. So, I'm going to move 1, 2, 3, 4, 5, 6 times to get into scientific notation. That's 4.4 times 10 to the negative 6. Be careful on those. I know I think most of you are pretty good with it, but sometimes people mess up on that negative and positive exponents. Put this over the number 1. Times sign, division sign. So I want to get rid of megajoules, right? That's what I want to cancel. I want to get rid of it. So let's just go ahead and get our conversion factor for megajoules to joules. Now, I'm just going to recite it. Again, you can go back and look it up. What you should see when you look it up, you should see this. I'll just write it up here. 1 mega blank equals 10 to the 6th blank. That's what you should see. In this problem, what is that blank? It's our base unit. What's our base unit? Joules, which you may know is a unit of energy, but if you don't, we'll definitely talk about joules later. And I know that Joule is the name of electronic cigarette, and that physics has been irreparably harmed by the presence of Joule. So now anytime I say Joule, it's funny, but still a unit, so we're still going to use it. All right, so you see here, what do I want to get rid of? Well, I don't want megajoule. I want to get joules, so I want to get rid of megajoule. So to get rid of this, right, I got to put it in the bottom. I'm not going to put it on top because that won't help. Megajoule goes on the bottom. You have to focus on the units when you do this. That's why it's called dimensional analysis, because we're looking at the units and treating them like numbers. So to cancel megajoule, it's got to go in the bottom. On top is going to be our other unit, which is joules. I'm just going to write a J. All right, so look it up. What number goes beside mega? Now, do not say 10 to the 6th because you associate 10 to the 6th with mega. Look at the notes. Look at what number's there. 1 is beside mega, so I'm going to put 1 beside mega down here. That 10 to the 6th goes on the other side. And this has to be the order you put in it. If you flip this, you're going to get it wrong. Because think about it. What are we saying? Remember, these two things are supposed to be equal. I'm saying 1 megajoule is 1,000,000 joules, right? A megajoule is like a lot. Mega is big. We know that, right? So a megajoule is a lot of joule. So it's got to be 1 joule is 10 to the 6th. It's 1,000,000 joules. If you flip it, right? If I put 1 on top and 10 to the 6th on bottom, then I'm saying that 1 joule is 1,000,000 megajoules, and that just doesn't make sense. It's not correct. So I've set this up. I'm going to cancel, megajoules cancel. That's it. So now I have on top, multiply across the top. I have 4.4 times 10 to negative 6 times 10 to the 6th joules over 1 times 1 is 1. Interesting. So we got 10 to the negative 6 times 10 to the 6. We add the exponents because we're multiplying. Negative 6 plus 6 is 0. So 4.4 times 10 to the 0 joules, or we know 10 to the 0 is just 1, so really it's just 4.4 joules. And hopefully you got that. That's where I'm going to end today's lesson. So once again, you've got a couple of practice problems. I didn't give you many. I think I'm asking you to, again, I kind of set it up like all the others on Schoology. So you have as many attempts as you want. I'm only giving you 3 problems. So again, I'm intending that you take the time, write it out, and do those problems. Again, this is the kind of problems you'll see on our quizzes as they come up, which our first quiz is probably we're looking at probably not next week. Obviously, I've got next week, or probably the next week. Yes, sorry, probably towards the end of next week. But I'll definitely let you know. Okay. Again, as always, if you have questions, please either email me, or so you can either email me with your questions, or you can simply just come to one of the Google Meets, right? So if you're doing this on Friday, if you're doing this on Friday, I actually am probably intending to have everyone meet on that next week, just to kind of check in and make sure that we're all doing okay. But in general, you can come to those Google Meets that are labeled or listed in like the virtual schedule. There we go. That are in the virtual schedule. So you can come to those. I'll be around there to answer questions. You're not required to come to them. I'm just there to answer questions. Or if you want to see me do more examples, or if you want to see it, I don't know, on the whiteboard or something, I could probably move the camera around, do it on a whiteboard, or whatever I need to do to help you. I know this stuff is abstract. And again, I know there are shortcuts. I know you can just plug this in and get the answer off Google in 10 seconds. I'm hoping that you don't do that, though. I'm hoping that you take the time to learn this skill, to do this, that you'll better yourself academically, and you'll be able to do this when it comes to the point next year and this year too. We're going to be using this quite frequently, so you'll be able to use it this year. You'll be able to use it next year in chemistry, and then again, there's a good chance you'll use this in college at some point. This dimensional analysis. And we're starting with converting because it's something you're familiar with. And then eventually you'll be doing stuff that you're not quite so familiar with. Okay? So that's all I have. Again, please contact me if you have any questions. See ya.